So our first lesson in this chapter will be called Measures of Center. And we do have objectives for this lesson. By the end of the section, you should be able to calculate the mean for a given data set, find the median and describe why the median is sometimes preferable to the mean, find the mode of a data set, and describe how skewness and symmetry affect these measures of center. So when we talked about graphs for quantitative data, we talked a little bit about symmetry and skewness, and these are closely related to measures of center. So I imagine a lot of you will already know how to find an average or to calculate the mean. If you don't, that's no problem. We're going to learn now. To find the mean of the values in a data set, simply add up all the numeric observations and divide by how many observations you have. So we actually did find the average of two numbers when we were doing the classes for the histogram. What we essentially were finding was the average of two numbers. But we can find such a mean no matter how many numbers we have. We just add up all the numbers and then divide by how many we have. So in mathematical symbols, you would express that like this. And the symbol that we use for the mean is x with the bar on top, and we will say x bar. So the way we read this is x bar is equal to the sum of x over n. In plain English, that just means to find the mean x bar, we add up all the data values, which is the sum of x, and then divide by how many observations, which is n. So we have the sum of x divided by n. All right. When data are quantitative and the frequency distribution is roughly symmetric, the desirable central tendency will be the mean. Then we'll have what's called the population mean. The mean value of a population we generally don't know. For example, if you were literally talking about the population of your city or your county or your state, that might just be too many people to actually ask every single person for a measurement. We usually do sampling, as we discussed when we did the introduction to statistics. So a lot of times we're just not going to know the population mean. But we do have a symbol for population mean, and we use this Greek letter mu, which is the Greek letter for the English letter M. The population size will be denoted by a capital N, whereas up here we used a little n. When talking about population size, we might use capital N instead of lowercase n. Okay, when all of the values of the population are known, we can calculate the mean. Like I said, we might not often be able to get values for every single member of a population, but if we do, we just add them up and divide by capital N. So for the data, find the sample size n, here's our data, and then calculate the sample mean. So we have 1, 2, 3, 4, 5, 6, 7 pieces of data. So n is 7. And the mean, which we call x bar, then it should be equal to, if we add these all up and divide by 7. So of course, we can use a calculator to do that. But your instructor, your professor, has actually created an Excel spreadsheet that can do this. So this is great because you don't have to buy any calculator. You should all get Excel for free for being a student of the university. If you don't already have Excel on your computer, then you can get it. You contact IT, or maybe you can figure out how to get it just by going to the website. And so your professor has created Excel spreadsheets that we're going to be using several times in the class, and the first time we're going to use one is now. We're going to calculate the mean. So in shared class files, you will find this Excel spreadsheet, and it's called mean. And it lets you put your data directly in. So here I'm going to put it, put it off to the side so that I can see my data here as well. Okay, so my data, I'm going to put the numbers in for the X values. So 75, 65, 90, 80, 75, and 100. And then for frequency, for each one I just have 1. And it's going to calculate the mean for me. So what you see is this first column, you're putting in your values. These are your X's, just like in the formula here. We're summing up the X's. So you type in each number. Then the next column, didn't mean to draw there. The next column, if I click with my mouse, is going to be the frequency. So it's titled F. And since each of these numbers just appears once, I'm going to put in 1. But if I had 2 90s, for example, then I could put 2 and it would count it twice without me having to type it twice. Then the third column is giving you the value X times the frequency. So since each one just has frequency 1, it's just giving you X back. Then what you're going to be looking for is down here. It's going to tell you N, which the question asked us to find, 7, and it's going to tell you the mean. So he has called it M here in this spreadsheet, but this is the number you're going to use for X bar. So our mean is 81.4286. Usually we'll round to 4 decimal places in this class. So 81.4286. That's going to be the answer to my question. X bar is approximately 81.42. And I think it was 86. Right. Okay. One other measure of center, instead of the mean, we can look at the median. The median of a data set is the middle data value when the data are put into ascending order. So that's critical here. Your data have to be in order, and if your data are in order, you just find the middle value. Half of the data lies below the median, and half of the data lies above the median. If the sample size is odd, if you have an odd number of things, then the median is the middle value, and it lies at the n+1/2th position when the data are put in ascending order. If the sample size is even, then the median is the mean of the two middle data values that lie on either side of the n+1/2th position. If it is not even, it says the n+1/2th position is not even a whole number, and the median in these situations don't necessarily belong to the data set. So that's also important to remember. Your median doesn't have to be in your data set. When data are quantitative and the frequency distribution is skewed, the desirable central tendency will be the median. A numerical summary of data is said to be resistant if extreme values, either very large or very small values, do not affect its value substantially. So this is super, super important. When the data is skewed, you need to use the median. Why do you need to use the median? Because the median is resistant to extreme values, meaning the extreme values do not affect its value substantially. Now before we said if the data is symmetric, then you want to use the mean. So a lot of times in life, you'll hear people talk about the average of this or the average of that. And what we just learned is that that is only good if we have symmetric data. But we often have skewed data, skewed to the left or skewed to the right. And if it's skewed to the left or skewed to the right, then we don't want to use the mean. The mean makes no sense at that point. We have to use the median. So this is something we're going to remember for the rest of our lives. If we have skewed data, we use the median because it's resistant, period. And then finally, the last central tendency we'll talk about is the mode. The mode of a data set is the data that occurs with the greatest frequency. A data set can have more than one mode. It could have 1, 2, 10, or it might not have any mode at all. If a data set has one mode, we call it unimodal. 2 modes, bimodal. Or more than 2 modes, we would say multimodal. If no data occurs more than once in the distribution, then it just won't have any mode. All right. When the data are qualitative, then the mode will be the desirable central tendency. So here we have a data set, 1, 5, 3, 4, 3, 2, 3, 7, and we're asked to find the median and the mode. Now remember we said to find the median, it's going to help us if we first put this in order. So let's do that. We'll have 1, then 2, and then I have 3 3s, I have 1 4, 1 5, and 1 7. I also want to know how many total numbers do I have. I have 1, 2, 3, 4, 5, 6, 7, 8 numbers. So n is equal to 8. On our previous slide, we were told when finding the median, we want to first find this number n and see if it's odd or even. If it's odd, then the median will be the n plus 1 over 2th data. So let's find out. N plus 1 over 2 in this case. Whoopsie daisy. N plus 1 over 2 is going to be 8 plus 1 over 2. So 9 over 2, and again in the last slide we knew that since it was even, we wouldn't even get a whole number when we did this, and that's okay. So we want to find the 4.5th data. What do we mean? We mean we want to find, this is the 4th data, this is the 5th data, and it told us to add them up and divide by 2. So 3 plus 3 divided by 2 is 3. So the median, in this case, is 3 plus 3 over 2, 6 over 2, 3. The mode is also 3 because we have 3 3s. I just counted how many. I have 3 3s. Of everything else, I only have 1. I have 1 1, 1 2, 1 4, 1 5, 1 7, so the mode is 3. So in this simple example, both the median and the mode are 3.